Welcome to this lesson on atomic radius. Atomic radius is one of the most important periodic trends in chemistry. Understanding how the size of atoms changes will help you predict chemical behavior and bonding patterns. Let's explore what atomic radius is and how it varies across the periodic table. The atomic radius is defined as the distance from the nucleus of an atom to the outermost electron shell. In other words, it tells us how big an atom is. Think of it as measuring from the center of the atom to its outer edge. This measurement is crucial because it affects how atoms interact with each other and form chemical bonds. To better understand atomic radius, imagine an atom as a sphere. At the center is the nucleus, which contains protons and neutrons. The atomic radius is measured from this nucleus outward to where the outermost electrons are located. This gives us a way to compare the sizes of different atoms on the periodic table. Atomic radius is measured in extremely small units called picometers, abbreviated as PM1 picometer equals 10 to the negative 12 meters. That's 1/1,000,000th of a meter. To put this in perspective, atoms are so small that millions of them could fit across the width of a human hair. Most atomic radii range from about 30 to 300 picometers. Now let's look at how atomic radius changes across a period. A period is a horizontal row on the periodic table. As you move from left to right across a period, the atomic radius decreases. This means atoms get smaller as you go across the row. This might seem counterintuitive at first, but there's a clear reason for this trend. Why does atomic radius decrease across a period? As you move from left to right, each element has more protons in its nucleus. More protons mean a greater nuclear charge, which is the positive charge in the nucleus. This stronger positive charge creates a stronger pull on the electrons. As a result, the electrons are drawn closer to the nucleus, making the atom smaller overall. Now let's examine the trend down a group. A group is a vertical column on the periodic table. As you move from top to bottom down a group, the atomic radius increases. This means atoms get larger as you go down the column. This trend is easier to understand than the period trend. Why does atomic radius increase down a group? As you move down a group, each element has additional electron shells added to its structure. More electron shells mean the outermost electrons are located at a greater distance from the nucleus. Additionally, inner electrons create a shielding effect that blocks some of the nuclear attraction. This shielding effect reduces the nuclear pull on the outer electrons, allowing the atom to expand and become larger.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.